Serena? All right, let's take a look at number 18. 18 said, I have negative 3 times the absolute value of y minus 3 is equal to 9. Do not split this. We do not split it until we get the absolute value of y minus 3 completely alone. This is when we split. Everyone's looking at the board. Everyone's sitting up. Chris, sit up. What do I need to do to get my absolute value alone here? What do I need to do to get my absolute value alone here? Jack? It says negative 3 times this. Excellent. I'll divide everything by negative 3. When I do that, my negative 3's divide out. Jack, what is 9 divided by a negative 3? Negative 3. All right, this cannot be negative. Whatever number is inside these absolute value, after I take that absolute value, I cannot have negative. Cannot be negative. This isn't to say the y can't be negative. When I take the absolute value of a number, the answer can't be negative. So this is a no solution. So Serena, do you see that? All right, do not split these until the absolute value part is completely alone on one of the sides. All right, what else can I do for you guys? Isabella? 40. Let's take a look at 40. All right, number 40 says, I have the absolute value of t plus 2.7 is equal to 4.5. Is this the one you're talking about? Okay. I need to get that absolute value completely alone. I cannot split it right now. What am I going to do to get that absolute value alone? Peter? Yes. I'm going to add a negative 2.7 to both sides. So I end up with the absolute value of t is equal to, well, I have the bigger minus the smaller, so I'm going to borrow here. So that's going to be 8, that's going to be a 1. So I have 1.8. Now I split this, because the absolute value is by itself. I have t is equal to 1.8, because that's exactly what that says, or t is equal to a negative 1.8. You good? All right, Chris, I want you to take your stuff, and I want you to go stand at one of those high tops right now. Yes, you. Take your glasses, take your pencil, take your stuff. You are not sitting down. You are standing. Do you understand? Got it. No sitting. Thank you. Choose anyone you want. You've got your glasses. You should be able to see. Do not sit down. Okay. What else can I do for you guys? Peter. All right, let's take a look at 39. 39 said, I have the absolute value of p minus 2/3 is equal to 5/6. All right, it is possible, Victoria did this, it is possible to do clearing fractions here. All right, so if I cleared fractions, I'm going to multiply everything by 6. So I end up with 6 times the absolute value of p minus 4 is equal to 5. Or what I could have done is I could have said, okay, my 2/3, if I multiply that by 2 over 2, I get 4/6. So I could have just done my equivalent fractions where I'm just dealing with fractions. So either one of these would have been a good method to use. How many of you guys thought to clear fractions? Awesome. So I'll finish that. The one thing to remember with clearing fractions is you have to keep that 6 outside the absolute value. All right, so now I'm just going to add a 4 to both sides. I have 6 times the absolute value of p is equal to 9. I'm going to divide each side by 6, and I have the absolute value of p is equal to 3/2. And then from there I split it. P is equal to 3/2, or P is equal to a negative 3/2. If you did not clear fractions, we just did our equivalent fraction work, so we have common denominator. Here I'm just going to add 4/6 to both sides, and I have the absolute value of P is equal to 9/6, and I would do the same thing. P is equal to, and this can simplify to 3/2. P is equal to positive 3/2 or a negative 3/2. All right, put this away, get your notes out. We need to talk about when we have inequalities with these. All right, your test is going to be the Friday we get back. Okay, so the Friday, we don't have school Monday, Tuesday, Wednesday, Thursday, then your test is Friday. Okay. All right, so today is 11/25. We are talking about 3.6 continued. So now what we're doing is we are doing absolute value inequalities. Okay. So what we're doing is we are going to be combining compound inequalities. God bless you. Compound inequalities. Sit up. No, you're standing. I'm not leaning over, you're standing. Okay, because if you fall asleep, then I'm kicking you out of my room and you're going to go down and sit with Mr. Vinsler, and then I'll explain to your mom why you're not in my room. So keep your head up. You are not falling asleep. I'm looking out for your best interest right now. Okay. So we're going to combine compound inequalities with absolute value equations. All right, so the things that we need to think about are, we have ands, we have ors, all right, we have splitting to apply the absolute value operation. So this is combining our compound inequalities and our ands and our ors. All right, so we're going to talk just about ands today, but I want you to see what they both look like. All right, so when we talk about splitting, so when we talk about absolute value equations, this is a review. So when we talk about absolute value equations, we have to have our absolute value expression equal to a constant. This is our goal. Because here, we split. It's when we have the absolute value term completely alone equal to our constant, that's when we split it. And we split with the expression equal to a positive constant, or the expression equal to the negative constant, whatever that constant happens to be. That's how we split it. So for those of you that were still struggling a little bit with the absolute value equations, here's another summary of how we do it. All right, let's talk about absolute value inequalities. This should say value in here. Inequalities. All right, there are two kinds. We have our and we have our or. Just like our compound inequalities. So let's look at what an and's going to look like, and let's look at what an or is going to look like. It all has to do with the inequality symbol. All right, so it's going to be the absolute value of an expression is less than or equal to the constant. That's what an and is going to look like. The or is going to be the same structure, the absolute value expression, but it's going to be greater than or equal to a constant. That's what they look like. And it's at this point that we will split them. So you still have to get the absolute value term completely alone. We want the absolute value on the left, the constant on the right, always. Once we have the situation with the absolute value by itself on the left and your constant on the right, that's when we look at our inequality symbols. Because that's what determines whether I have an and or an or. An and is going to be a less than type symbol. An or is going to be a greater than type symbol. All right, so let's take a look at what this is going to look like. We're just going to focus on ands today. Ands will have story problems with them, ors will not. Just like with compound equations. Who needs to see what's up there? Or compound inequalities. Okay. Is value good? Awesome. Okay, so let's take a look at a couple skills, and then we're going to do a story problem. Alright, so I want you to solve. Alright, so if I have the absolute value of 2p plus 5 is less than or equal to 11. Alright, we have our absolute value expression on the left. We have this less than symbol, and then we have our constant. This is an and. So we are going to be focusing on ands right now. This is an and because it's a less than or equal to symbol. Alright, so what we need to do is we need to split this. We are going to split it into an and solution, an and inequality. Remember, that's when we have a minimum, a maximum, and the expression in between. All right, so please pay attention to what you're going to do. All right, what you're going to do is you're going to rewrite exactly these two things, all of that. You're going to rewrite that whole thing with no absolute value. So I have 2p plus 5 is less than or equal to 11. So I rewrote that entire thing. We dropped the absolute value symbols. But then what we also do is on the other side we do exactly the same symbol again. So we put that symbol again right here, and then we do the negative of the constant. And now we just solve. So I have a negative 11 is less or equal to 2p plus 5, which is less than 11. All of us solve that. So we're going to add a negative 5 to both sides. So I have a negative 16 is less than or equal to 2p, which is less than or equal to 6. I'm going to divide each side by 2. Our inequality rules apply. So if that was a negative 2p, I would have to divide by a negative 2 and flip the symbols. So there is our solution. Let's talk about what a story problem might look like. Okay, how many of you guys are NFL fans? That's the National Football League, for those of you. Okay. Do you guys remember that one year where Tom Brady had the issue? Deflategate, do you guys remember that? Okay, so every ball, a football, soccer ball, basketball, volleyball, there's always a range of appropriate or acceptable pressures inside the ball. Listen, there's always acceptable ranges of pressures inside the ball, okay? And if you're outside that range, it's not acceptable, which is where they found it. The pressure inside the ball was not enough. It was too low, and so it was easier to hold. All right, and they said that he was cheating or that they were cheating. All right, this is an absolute value inequality. So let's look at an example of what I'm talking about, those varying pressures. So let's say that we have an NFL football has an acceptable range of air pressure to be able to use it. All right. The air pressure, the ideal air pressure, and I'm totally making this up, you guys. The ideal air pressure in the ball is 12 psi, pounds per square inch. All right, the ideal air pressure in the ball is 12.5 psi. It can vary by, let's just say 1 psi. Let's say 2 psi. I'm totally making this up, so it doesn't matter. 2 psi to still be acceptable. What is the range of acceptable air pressures? All right, so this is an example of when you can use an absolute value. All right, so let's take a look at what this is going to be. The formula is always going to be the absolute value of the actual measure minus the ideal measure is less than or equal to the varies by. This is always going to be the formula. It's your absolute value of your actual measure minus your ideal measure is less than or equal to the varies by. Because it has to be it can't be any more than that varies by. All right, so the difference in the measures cannot be more than the varies by amount. That's what that means. All right, well, I don't know my actual. There's my x. This formula is the same no matter what it is that you're measuring. Okay? So, I have the absolute value of x minus, what's my ideal pressure here? What's my ideal pressure, Matthew? 12 is less than or equal to, Matthew, what's my varies by? 2. Because it can vary by 2 psi. So I have the absolute value of x minus 12 is less than or equal to 2. I need to split this. Remember, write down exactly that same expression, that same inequality, without the absolute values. So x minus 12 is less than or equal to 2. But then what else do I have to add on to the other side? Serena? Yep. And a negative 2. And now I just solved this. I get 10 is less than or equal to x, which is less than or equal to 14 psi. So this is an and absolute value inequality story problem. Questions on this? Yes, Charlotte. You're writing it as a sentence. I just don't have time to write as a sentence. So write as a sentence. You guys good? Okay. Did we have a late night last night?